Okay, question number 5. A 300-gram glass thermometer, initially at 24 degrees Celsius, is put into 164 centimeters cubed of hot water at 92 degrees Celsius. Find the final temperature of the thermometer, assuming no heat flows to the surrounding. The specific heat of glass is 0.2 calories per gram times degree Celsius, and of water 1 calorie per gram times degrees Celsius. As usual, let's write down what we know. So there we have it. Notice that anything with a 1 means glass, and everything with a 2 means water. In this case, because I was given volume, I need mass. I know that volume and mass are related by means of density, so I know the density of water. And that's going to be 1 gram per centimeter cubed. All right, there'll be a heat transfer between the water and the thermometer, and at some point it'll reach thermal equilibrium. So we know that Q1 is equal to Q2 because the heat transfer out of the water goes into the thermometer. So thermometer will increase its temperature. All right. So we can expand our equation. I'm going to try a different pen. Let's see if this is better. All right, so don't forget, as I've said before, for our delta t's, we want a positive number. So if you think about it, if you think about the system, the highest temperature that we'll have will be the temperature of the water, okay? So that means the thermometer will increase its temperature, therefore the final temperature, which is what we're looking for. I forgot to write it down. Let me do that real quick. That'll be higher than the initial temperature of the thermometer. So then we'll get temperature final minus temperature of the thermometer. Conversely, for the water, in this case the water will be hotter than the final temperature. Okay, because we know these two are, these two are the same, temperature final, we're going to go ahead and distribute. And of course, what we want is to have our T final on the same side. So I'll move this one, and then I'll move this one so that I only have T finals on the left and the rest on the right. Change a color here real quick so you know what I'm doing. And of course, whatever I do to one side, I'll do to the other. So these two will cancel, and these two will cancel. This is what I'm going to have after that. Now we can factor out T final. And of course, because we want to solve for T final, we'll just divide by my expression inside the parentheses. Okay, we're almost done. We do not have mass 2. Yeah, we don't have mass 2. We have mass 1. We don't have mass 2, but we have volume. Meaning that I can say, okay, I know that density is equal to mass divided by volume. Therefore, if I multiply both sides by volume, I'll get that mass is equal mass is equal to density times volume. So then my equation would look like this. Notice how Instead of mass 2, I've replaced that with density times volume, of course, of the water. Now we'll just plug in our numbers. That is a lot of numbers, but that's how it should be done. Be careful when you plug in your numbers. Now, just for reference, let me put this in the calculator and tell you what I got. I got 73.7587. And because I'm looking for temperature, that is degrees Celsius. I didn't have to convert grams to kilograms because all my units are in grams. So everything works out nicely. Here, my centimeter cube, these two will cancel, so there's no need to convert grams to kilograms. If you do, you'll have to change your value for a specific heat, and that would make it just messy. So there you have it.